So, hello everyone, welcome to the session. And yes, the prelims, IBPS AFO Prelims is over, and the mains examination. I hope you have the idea that the date of mains examination is 9th of November, right? The IBPS AFO Mains examination is on 9th of November. That means we have left with just 2 months, right? And yes, along with the reading, along with the notes revision, the practice is equally important. The 50% weightage should be for the revision, reading, and the 50% weightage for the MCQ solving. Just divide your time accordingly and solve as many MCQs as possible, because that is the important uh, part of your that should be the important part of your preparation, because that is what you're going to do in the actual exam. Okay, so yes, Agriclarity is bringing some lectures, some practice MCQ lectures for you for more clarity, for more revision on different subjects of AFO Men's examination. Okay, so yes, today we are doing that practice on soil science. So let's start our discussion on the soil science MCQs. Okay, so yes, the first question is in front of you. So the dash approach in soil science studies soil as natural body, focusing on its origin, classification, and description, while dash approach emphasizes soil properties in relation to plant growth and productivity. So, yes, correct answer is option B, that is pedological and edaphological approach. So, in pedology, what we are studying, we are considering soil as a natural body, and we are studying the origin, the classification, and description of the soil as a natural body. Okay, and in edapology, it is like a practical approach, you can say, where we are studying soil in relation to the plant growth and productivity. Okay, we are studying how we can increase the plant's growth, plant yield, plant productivity, efficiency, by applying different chemicals or whatever different methods. Okay, so I hope you are clear with this pedological and edaphological approach. Here in pedology means soil. Okay, so here we are studying soil as a natural body and just studying its history, classification, origin, the basic study. But the edaphology is like a practical approach where we are studying the soil in relation to plant growth and productivity. Okay, this is important concept and often confusing, so please revise it. Okay, so yes, this was the first question for today. Let's discuss the next question. So the question is, which of the following is not igneous rock? So yes, we know that we have three types of rock, right? Igneous rock, sedimentary rock, and metamorphic rock. Okay, and you should have at least one or two common examples ready with you for these rocks, because they are again important. Okay, so tell me which of the following is not igneous rock. So yes, the answer is limestone. So what is the limestone? Is it sedimentary? Is it metamorphic? So yes, it is what? It is sedimentary rock. Limestone is sedimentary rock formed mainly from accumulation of calcium carbonate, okay, often from shells in marine organisms. So that's why the option is E, as it is not igneous rock, it is sedimentary rock, okay, and all other are igneous rock along with the basalt, right? So yes, this was the question on rocks. Next question is in front of you. Which of the following clay minerals belonging to 2 as to 1 type structure are classified as expanding clays? So which of the following group is the 2 as to 1 expanding type? So yes, we all know that it is montmorillonite or vermiculite, which are often present in the black soil, right? So yes, mortomolonite and vermiculite are the expanding type of clays, right? The option will be D. So yes, next question is in front of you. The mineral dash, commonly known as rock phosphate, acts as a primary source of soil phosphorus. It decomposes with carbonic acid and often becomes immobilized in calcareous soil due to reaction with clay and CaCO3. So what is the mineral which is also commonly known as rock phosphate and as used as a source of soil phosphorus. Okay, this rock phosphate concept and the source of soil phosphorus concept are there in your PYQs. You can go and see. So tell me the answer for this. So yes, the answer is apatite. Okay, we are using this mineral as which is also known as rock phosphate for the phosphorus application to the soil. Okay, and can you tell me this phosphorus? What is the major role of phosphorus in crop? Can you tell me that? Yes, it is energy transfer. Okay, so yes, for that reason, that is the main function of phosphorus. Next question is in front of you. Which one of the following processes cannot be regarded as form of chemical weathering? Okay, so we know that we have three types of weathering. First is physical weathering, second is chemical weathering, and third one is biological weathering. Okay, so and weathering is what? It is a disintegration or decomposition of rock into small particles or which is going to create or form the soil layer. Okay, so we have three types. So just tell me which of the following is not a chemical process, chemical weathering, chemical form of weathering. The options are hydrolysis, carbonation, oxidation, hydration, or the frost action. So we know that it is a frost action, right? Here, why? Because here no chemical is involved in weathering and disintegration and decomposition of that particular rock. But what is happening? We know that in the soil we have different fractures or crevices. What happens? Water will go in that crevices, and because of low temperature, it will be converted into ice. And we know that volume of ice is more than the volume of water. So this ice is going to create the pressure on the walls of these crevices, increasing its length or the overall size. And in the long term, it is going to make it brittle and it is going to break down it into a small fragment. So here the chemicals are not involved, but that conversion of water into ice and that pressure buildup is the reason. Okay, and we know that hydrolysis, carbonation, hydration are all are the chemical form of weathering. Okay, I hope you are clear with the idea. So yes, let's discuss in short what are different forms of weathering. So first is physical, second, as I said, chemical, and third was the biological. Here, what is happening? Disintegration is happening. Here, decomposition is happening, and here both disintegration and decomposition. So biologically easy, man, animals, higher plants, and the roots and the microorganisms are all involved or are acts as the agents of this biological weathering. Here, what is happening? The physical condition of rock, then change in temperature, as I said, then H2O, water movement, that is freezing that we considered, then alternate wetting and drying, actions of glaciers, action of wind, and atmospheric electric phenomena all acts as the agent of the physical weathering. So yes, chemical weathering. In chemical weathering, we have hydration, hydrolysis, solution, carbonation, oxidation, and reduction. Hydration is about attachment or combination of water molecule. Hydrolysis is about removing of that water molecule. Then solution is about uh, uh, whatever soluble part of the rock is dissolved in that solution and it will be separated from the rock. Okay, so yes, in carbonation, what is happening? The CO2 is going to get mixed with the water, forming the carbonic acid, which is again going to dissolve the minerals around it. Okay, particularly the limestone and calcite. So yes, next is oxidation and reduction. We all know. So yes, these are some of the processes that acts as an agent for different types of weathering processes. Okay. So yes, next question is in front of you. Which of the following represents the correct chronological sequence of soil profile development stages? So what is it? So the correct answer here is juvenile, virile, and senile. Okay, option D. So yes, let's discuss these 5 stages of weathering in soil formation. So first is initial and the last is final. These are easy to remember, right? So yes, first initial where the unweathered parent material is present. The parent material is in the form of like it is a stable, okay, it is unweathered and stable. The juvenile is the phase where the weathering process actually started. So if someone is asking you in which of the following stage actual weathering starts, so it is juvenile state, okay. So weathering started, but most of the part of that rock is still unweathered. Next is virile. Virile is like a half, okay. Half is done, half is yet to be done. Which was the half that was easily weatherable is fairly decomposed, increasing the clay content. But the half which is still under the process of weathering, okay. Next is senile. Senile is the final stage of decomposition where most of the 90% part of the rock is weathered, just the resistant part of the rock is remain, okay. And final is like the final end of the process. All the prevailing environmental condition agents acted on it, and all soil development process is completed, okay. So these are the 5 stages of soil formation. So juvenile, J, V and S, okay. J, V and S. V is like middle, juvenile is the first starting, and senile is the like the end of the decomposition, okay. So yes, these are the stages. So yes, let's discuss the next question. The soil forming processes in which sodium ions accumulate on exchange complex of clay and organic matter, leading to development of sodic soil or solens, that is known as what, okay. So yes, it is the solanization or the alkalinization, okay. So we often get confused between the salinization, solanization, its alternative names, right? So let's clear that confusion today. So yes, we have different types of like soil forming processes, like fundamental soil forming processes, special soil forming processes, and this is part of that particular syllabus point, okay. So this is mostly confusing part, so let's discuss that, okay. Salinization, desalinization, solanization, and solidization. So in salinization, what is happening? The accumulation of soluble salt. The keyword here is soluble salt and not just sodium, okay. Salinization, accumulation of sodium salts. Desalinization is removal of those soluble salt. So that's easy, right? Here the keyword was soluble salt. Salinization means accumulation and desalinization means removal. Next concept is solanization and solidization. What is happening here? The key concept that you have to remember here is sodium ions, okay? Sodium ions particularly. So solanization is accumulation of sodium ions, and the solidization means removal of that exchangeable sodium ion, okay. So I hope until now you're clear. So this sodium ion is accumulated where? It is accumulated on that exchange complex, okay. The sodium has positive charge and this clay has a negative charge. So this in solanization, what is happening? There is accumulation of sodium ions on the exchange complex of clay and organic material, leading to the sodic soil, which is not desirable because we want the proper balance of all the ions, okay. And more concentration of sodium is not desirable. So solanization leads to sodic soil or solen soil, and it is not desirable. And in solidization, what is happening? It is removal of exchangeable sodiums from the soil complex. So by replacing it with the Ca plus Mg plus, resulting in dispersion of clay and leaching of sodium salts. Okay. So I hope you're clear. Salinization, accumulation. Here the keyword here is soluble salts. So salinization is accumulation of sodium salt. Desalinization, this desalinization means removal of sodium salt, okay. And solanization means here the keyword is sodium Na ions, so Na plus ions, okay. Solonization is accumulation of those sodium ions, and solidization, here was also desalinization, right? So diazation, when D is coming in that, removal of those sodium from the soil complex, okay. I hope you are getting the point. This is important concept for both NABARD and AFO, so please go and revise it, okay. So yes, next question is in front of you. Which of the following statements are correct about laterite salts? Okay, so the first statement is they're rich in oxides of iron and aluminum. They harden on exposure to air and often used in brick making. They're acidic and more suitable for plantation crops like tea, coffee, rubber, and cashew. So tell me which of the following statement or statements are correct. So yes, all the statements are correct, right? They reach in yes, they reach in oxides of iron and aluminum. Yes, they harden on exposure to air, and for that reason they used in the brick making, okay. Then next is yes, they are acidic and they are suitable for the plantation crops, okay. So yes, let's discuss. Let's discuss the major soils of India. Major soils of India is again important part of your syllabus. Let's discuss it in brief. Okay. So first is alluvial soil. Alluvial soils are deposited by the rivers, and they're majoritarily present in the Indo-Gangetic plain, and also alluvial soil form the majority percentage of the soils of India. Okay. Next is they are fertile, they are rich in potassium life, but they are low in nitrogen. Okay. They are low in nitrogen. Next, the khadar is the new alluvium, and the bhangar is the older aluminum. Okay. Next is black soil, is also called as a regur, is best for cotton. Also, it has a self plowing ability, and its origin is volcanic. Okay. Then red soil, which is categorized as omnibus group, where it is formed, or its origin is the weathering of the crystalline rocks. Okay. And red is due to ferric oxide, and it is found in the regions of low rainfall. Next is laterite that we discussed. It is found in again the higher rainfall areas, and it has low fertility and is acidic, but yes, it is good for the plantation crops like tea, coffee, cashew. Okay. And it is used in the brick making, and this also we seen, right? It is primarily rich in the iron and aluminum oxides. Okay. Next is arid soil or desert soil. So here what is happening, the soil is saline in nature, and it has low organic matter and moisture content. Okay. And it is found in the part of Rajasthan, Gujarat, and Haryana. And mountain and forest soil, they are rich in humus, they are acidic and suitable for tea, spices, and fruit plantation type of crops. Okay. So yes, this was the revision card for the major soils of India. So please go and check out our Agriclarity Telegram channel, where we are posting daily these type of revision cards for different subjects, including agronomy, soil, extension, economics, pathology. So you will get daily one card, revision card, which will really definitely help you before your exam. For fast revision, these cards are really good. So please go and check out our Telegram channel Agriclarity. Link for the same is in the description. So yes, please go and check out our YouTube channel Agriclarity. The link for the same is again in the description box. So we covered many concepts in depth for different subjects. You will see the playlist for agronomy and soil science and other subjects. So please go and check those out, because we covered most important topics for your examinations. Okay. So yes, let's move to the next question. Which of the following is commonly used for reclamation of acidic soil? We know that we use lime and dolomite. Okay. So lime and dolomite is used for the reclamation of acidic soil, as they are most effective neutralize soil acidity and raise the pH, which is going to improve the nutrient availability. So the answer is lime and dolomite. So yes, let's revise the classification of salt affected soils. Okay. So first is a saline soil. Saline soil is rich or it has a high soluble salt, and when soluble salt is more, it is going to conduct more electricity. Okay. So so that's why EC, that is electric conductivity, here is more than 4. In the sodic or sodic soil or alkali soil, the there will be, it has a high sodium level. In the sodic or alkali soil, what is happening? It has very high sodium levels. That is, Na level is more on that exchangeable complex. And for that reason, the exchangeable sodium percentage here is more than 15. Okay, you are getting my point, right? And the saline sodic soil has both the issues. For that reason, it has high electrical conductivity because it has high soluble salt, and it even has high ESP because it has more sodium ions on that particular exchangeable complex. Okay, so I have a question for you. I want you to comment the answer for this question in the comment section. The question is, dash is commonly applied for reclamation of sodic soil. So please comment the answer for this in the comment section. So yes, please go and check out our test series course, the IBPS AFO 24/7 test series course. You can go and visit the Clarity for Sure website. The link for the same is in the description, and this course will give you 200 plus high quality tests. And so please go and check it out on the Clarity for Sure website. Thank you so much for watching. Best of luck for your preparation, and please be ready for more such a MCQ practice session in coming days. See you in the next session.